Start back on you. So
There you go.
at any time when we have technical difficulties, we plan it. Give you guys a young champion challenge. So there's a famous quote from Henry David Thoreau: "Not until we are lost, we begin to understand this." And I will end today's presentation with another image. So along those lines, I want to look at something first. Is both lost and found. And those are asteroids. Asteroids are fascinating things. They're completely unlike what you see in the movies. In the movies, they're as dense as snowflakes. In reality, what would you see? If you were standing on one asteroid, standing, so little gravity. If you were floating, hanging on with your fingernails to an asteroid, what would you see for the nearest of us? Anyone, take a guess. Nothing. Right, very good, Paul. Usually, they're a faint star or nothing. There are millions of miles apart from each other. So the asteroids are spread out. I'm talking about the ones between Mars and Jupiter. Asteroids use some very interesting things depending on gravity. Every gravitational body, every major body, has gravitationally stable points around a balance. For instance, the Earth is in balance between a pull from the sun and the moon. The sun overwhelms everything, it's bigger. So we have these points L, Lagrangian points, 1, 2, 3, 4, and 5. Some of these you might recognize have been famous. The L5 Society wanted to put a space station here, a stable point 60 degrees behind the Earth and the Earth's orbit. They since renamed themselves the National Space Society. L2, everybody should remember where a famous object is. Just mentioned it a few minutes ago. The Webb telescope. And L1 is near the sun. We want to put something there to watch for near-Earth asteroids that may collide with us that other space instruments can't see because the sun is blocked. We're going to put a dedicated instrument there. That's a proposal from the NSS, National Space Society. In science fiction, alternate Earth was here in L3, hiding behind the sun, along with that lens. Well, in the solar system, everything is in a gravitational dance, being pulled on by everything else. From the sun's pull and Jupiter and the other planets, something put here would soon drift out and become visible. So in case you're wondering, there's no alternate Earth. There are all kinds of interesting asteroids. Today I'm going to tell you about one that we call, in scientific terminology, weird asteroids. The ones that come close to Earth, all these do. Some cross the orbit of Earth and give them names like Apollos or Arcturus, all depending on how big the average size of it was it is. Some asteroids do this horseshoe-shaped orbit around both the L4 and L5 points and the sun. And surprisingly, astronomers call it a horseshoe orbit. You see where things are going here on how we do science terms. So there are asteroids that come near the Earth that could be potentially a danger if they strike the Earth. And they come in several categories. Trojan asteroids, horseshoe-like asteroids, things like only horseshoe orbit. Quasi-satellites, compound orbits, temporary satellites are Juno asteroids, totaling over 50. And why do you want to keep track of these things? Because we don't want a collision like what happened in 1908 between Tunguska, which is also a chapter of my book. In that year, a 20 to 30 megaton explosion happened over the Siberian forest. If it had hit a city like Manhattan, would have obliterated that city. We want to watch out for things that big. And that thing was about 50 meters on water, on the order of 200 feet. So let's start with Trojan asteroids. We have these that circle Earth's L4 point up here, far away, millions of miles. James Webb is not quite 1 million miles from us. You can see this is much further. And they are in a pretty stable orbit 60 degrees centigrade. The Russian vibrators do this weird pattern coming back. Largest one every 770 to 780 years to do a whole circuit. So it'll come back occasionally and be close to us, but millions of us, so don't move. This thing is about 3 miles across, and it's true with me. There's quasi-satellites. When we say, come on, say it quickly, this is the closest one, only 41 meters, 125 feet across. These have an elliptic orbit that's not a circle. Everything in the solar system has an elliptic orbit. The Earth, even the Earth, is a closer near the sun. In winter, for the northern hemisphere, winter, where is the Earth? Closest or furthest from the sun? Closest. So we got some clever astronomers. You can't fool them. Another odd one of these quasi-satellites is 2023 FW13. These names very easy to remember for these asteroids. They found it in 2023, but they looked back at old photographs. They found it again in 2012, so they were able to refine the orbit. The more points you can measure further back in time, the more accurate orbit. This thing, the orbit is stable for this asteroid, 2023 with 2013, for about 4,000 years. There are asteroids with compound orbits. There's an animation of one of them. 2020 CD3. Very sexy names, very easy to use as asteroid names. So over long periods of time, it doesn't pass around the Earth and the orbit of the Moon. And 5 or 6 temporary satellites that range between around the Sun and far from the Earth, but the clock in the years specific followings. You can sort of think of these things as mini moons. Earth typically has more than one temporary satellite, 1 meter, about 3 feet across. So can we easily detect it? No, not even with the world's most powerful telescopes. Too small. There are Arjuna asteroids, very much like the Earth's orbit. These are small, named after a central European Madhava. But what was the weirdest? The weirdest asteroid is one I'm going to talk about. It was not this one. This was Elon Musk's cruiser sent to space. It does come back to us every time. I'm not talking about that one. That's pretty weird. I'm talking about one that was discovered by the Panoramic Survey Telescope and Rapid Response System, otherwise known as PAN-STARRS, because PAN-STARRS, it's easier to say when the Panoramic Survey is over the back of it, but try it. This is at the Haleakala Observatory in Hawaii, the island of Maui. Some of you may have visited, some of the astronomers in the audience, I'm sure have visited some of the world's largest telescopes. This thing has a mirror almost 6 feet across. It is dedicated to finding NEOs. What is an NEO? Answers from the audience, by the way, are not coming.
Near Earth orbit.
Near Earth orbit, right. And so an NEA is a near Earth asteroid. On September 17, 2020, this instrument found something truly weird, better than science fiction. It found something weirder than these 4 satellites, and one of my favorites is WT1190F, which is turned out to be space TV. Now, if I were the astronomer's naming center, I would not have used WTF 2018, 1882. Turned out to be the Snoopy module, Apollo 2, 1969. Did people go to the moon in 1969? Believe it or not, yes. Contrary to what you've heard, people walked on the moon. 6Q0B, I can't even say this. This was an artificial object. An upper stage of the Saturn V rocket, Apollo 12, second class mission to the moon. That was discovered in 2008. None of these were weird enough for my weirdest asteroid ever. This is the one in my book. This is 2020 SO. And 2020 SO was discovered in 2020 to do this weird looping orbit, kept it close to Earth and Moon temporarily. So it became what we call a mini moon. And in respect to the Earth-Moon system, this is what the orbit of 2020 SO looked like between 2020 and 2023. So what happened to it ultimately? It left again, came close to the Earth, spent a few months, left again on its way to the sun. What does this orbit look like in respect to the sun? Well, it is an independent object going around the sun with its own orbit. It depends on your frame of reference. Remember, Einstein said everything is relative. Relative to the Earth and Moon, because it's weird loop. Relative to the sun, it has its own orbit that intersects the Earth about here. Ready? Watch here. Very close to Earth, coming inside the orbit, becoming an Atira. So it changes its characteristics. The Earth has been known to alter asteroids by the pull of its gravity. In 2029, on April 13th, some of the younger members of the audience will be older than them. Maybe they'll have a telescope. They'll be able to see the asteroid that comes close, name of which I've forgotten because I'm Apophis, pronounced by Neil deGrasse Tyson, Apophis. That is incorrect. The Egyptian is Apophis. I actually done the first thing. It took me a while to learn that. Apophis is huge. It's about 3 football fields in size. If it hits anything, we'd be in trouble. But we know its orbit and we'll miss it.
Okay, that was one question. How close are these again going to be?
The things we've been talking about, millions of miles, the ones that come within the orbit of the moon are the ones we're concerned about. Apophis comes so close at 20,000 miles, it's within the orbit of our geosynchronous satellites. Super close. And originally, when discovered, we thought it would hit us. We know for sure it will not. It's due back again in 2036, where it will miss us by over 1 million miles. But after that, we're going to keep careful measurements on the
It's within the orbit of the satellites. Is there expected to be any destruction to the function of the satellites?
Excellent question. Is there going to be disruption to our geosynchronous satellites? No, it will be far enough that we'll miss the angle it's coming in. But the Earth's gravity is going to alter the orbit of Apophis from one type to another because the orbit will extend. The Earth's gravity will change the asteroid's orbit, just like this. Well, now, something mysterious happened in 1966. We lost track of something. We were supposed to send Surveyor 2 to land a soft landing probe here in Sinus Medii, which means middle of the moon, a small sea. This is a sea of water. Look at this. Frozen lava, right? These are cold, dark seas on this side of the moon. The other side of the moon, just about the moon, facing us, about the man of the moon. So what happened? Well, a Surveyor 2 spacecraft missed. There was a mid-course correction that was never happened correctly. The upper stage of the central rocket missed the moon. The Surveyor crashed not far, thousands of miles, not far from the crater Copernicus, a nice bright crater. As you can see in the amateur instruments that are going to be run by some of the amateur astronomers in this audience. So do come back for an observing mission. Well, through a large teamwork effort from several teams, we discovered exactly what that thing was. They used the Pan-STARRS instrument that discovered 2020 SO, the large binocular telescope, the infrared telescope facility, and Vishnu Reddy, associate professor at the Lunar Planetary Lab, University of New. The large binocular telescope color observation showed that this thing was not invisible. What was it? Spectroscopy. Well, the IRTF to get a spectrum of this object. And the problem was it was moving too quick. Most of these asteroids travel faster than 20 kilometers per second. So Reddy compared the spectrum of this thing. He had a suspicion that this looked suspiciously artificial, like metal. And so he compared it with the spectrum of stainless steel, particularly type. Could it have been the lost Centaur D, lost in 1966, found 54 years later? How could we know? Well, since they couldn't get a good spectrum from the thing that was moving too fast, he looked for something similar. They found another old Centaur D from 1971 orbiting the Earth, this time moving more slowly, and compared the spectrum, and it was a perfect match. Stainless steel 301 confirmed it was the lost Centaur D rock, which looks like this. This is the thing in construction, partially done. From this picture and a few dozen others and diagrams, I was able to reconstruct what the original spacecraft looked like before it was damaged by meteorite impacts from ultraviolet radiation. That's what made it so difficult to determine the spectrum. The thing had been damaged over 54 years, Canadian students. And from this, I created the virtual reality object, 3D object that you can play with any pointing device or in figures once my book's published. Or you can go to my website, which I'll advertise later, and play with 3D objects for free. This is called a VRO, virtual reality object. You can spin it, you can zoom in on it for detail. You can see all the work that went into the several months that it took to make this. Luckily, I was able to purchase someone else's diligent work on the rockets down the road. There are all kinds of free 3D objects that you can either use to build your own electronic model or print.
Sorry, a quick announcement. Does anyone own a Mazda with a sunroof? It's starting to rain and the sunroof is open.
Oh, that's okay.
Mazda 350.
Yeah, it's okay.
So the car will get it now.
Yeah, it's actually a part-time boat.
You know what? If it doesn't work, we can launch it to space to join Elon Musk.
No,
Probably needs a good cleaning.
So this is what we call virtual reality. I'm unable to return. That's it, folks. That's the end of it now. So that is an object that was that was lost and found again. I also created an animation to show what it would be like to have followed the Centaur D on its trip past the moon back in 1966. There is sound with this, but it's this is sped up 5,000 times. Took several days to get to the moon. Just as it did for the Apollo astronaut. There's the impact site. On its way. Now, why didn't we see stars for the entire journey? Same reason that when you see pictures of the stop. The same reason that when you see pictures taken from the moon by the Apollo astronauts, we don't see stars. Why not?
it's too much sunlight.
Too bright, right? The exposure for the camera, either whether it's film or electronic, whites out the stars. And if you were in space with the Earth visible or the satellite in close up or the moon, you would not see the stars. Space artists will take liberties. I'll show you stars in the background. The Milky Way is a planet in front. That's artistic license. The space artists I belong to the International Association of Astronomical Parties. So you can see my work on my website. So the 2020 ESO artificial satellite went from becoming an Apollo asteroid to an Epira asteroid. Its orbit is permanently changed. Brandon Spector had a great goodbye from himself and left again in 2021. Don't worry, told me that. He said, Godspeed, Mini Moon 2020. You built you, abandoned you, and now you abandoned you. What a great film. Is it coming back? Yes. 2036. It will be about the same distance as the James Webb Space Telescope. It will not collide with the James Webb Space Telescope. Don't worry. We'll have another chance to see this asteroid. Now, what about something lost permanently? It's the other chapter of my book. I'm talking about something that happened just before the first artificial object ever sent by human beings into space. Some of us here are old enough, were alive at the time. I have to admit, I was yep. You can remember when the first object was sent to space. So now we have tens of thousands of artificial objects over the Earth and ring of garbage. Some of the ones that it was October 4th, 1957. This sparked a space race. And educational toys like this one, which still exists today, which I own, were the rage. They blanketed the market. Kids could buy them and build weather vanes and space stuff and orreries like this, showing the relation of Earth, Sun, and the Moon. Is this to scale? Is the Earth that close to the Sun? No. Is the Sun that small? No. Is the Moon that close to the Earth? No. This kid back in 1959 was inspired by science toys, inspired to study astronomy, and wondered about these mysterious happenings in the past. What was that little black spot that crossed the sun in 1859 and became the planet Volta? What was the thing that got launched into space? Well, it's family. It happened near Area 51. Let me show of hands. Anybody ever hear of it? Yeah, just about everybody. Right? Aliens? I don't know. But you can visit the Nevada hillside, just don't try to go in. Meet on the outside. The Nevada test site was very interesting. In 1907, they were doing tests of nuclear explosions, and they blew up a whole bunch on the ground, creating craters. Until the early 60s, when I was a kid, everybody thought the moon craters were volcanic, made by volcanoes. Nobody realized that impacts could happen from giant meteors. William K. Hartman, astronomer in Arizona, was the first to do detailed studies of moon craters and put forth the lunar impact hypothesis, which we now know is true. There were 29 tests, 29 explosions, all kinds of things, including tests on the effects of structures and people. So now we have to stay away from it. This happened between May and October of 1957. Why is this important? Because this artificial object, first object into space, was it real? Two of those 29, Pascal A, Pascal being some of the weirdest numbers. This thing, Pascal A, was a small nuclear device weighing a few pounds, put in the bottom of a well dug 150 meters, or almost 500 feet deep. Narrow well, 4 feet across. No cap at the top. This thing blew up and became a giant Roman candle. Robert Campbell was the test director. He had a great quote. He said, we dug this thing, put it in the bottom, we put a concrete block near the top with camera equipment, stuff to record measurements. Blew it up, and it was the biggest darn Roman candle ever saw. It was. Why? Well, because it took them so long to get it set up. According to Robert Brownlee, who has a great historic description, which you can find this online. He said they've been working, and it got dark, and it was supposed to go back to base, back to Mercury base, go to bed, get rest, come back the next day. Well, they couldn't do that. We're running out of time. They said, why don't we shut it off now? So they did, and it was the world's finest Roman candle. Blue fire shot hundreds of feet in the air, which I'd love to see. If you think that was bizarre, my book talks about Pascal B, which happened a few months later, August 27, 1957. Again, 490-foot hole, a concrete block with equipment to take measurements. But this time, instead of putting it at the top of the hole, put it near the explosion. This is critically important. And on top of that, some fool decided, let's weld a 1-ton iron cap to the top and see what happens. This thing weighed a ton. It was 4 feet across, solid iron, welded to the top. What happened? Well, nothing should. Nothing. Because when you blow up a small nuclear device, by the time you get to a few feet away, a few dozen feet away, the force of the explosion is dissipated to about the same as a conventional. So nothing should have happened. You can hear more about this in several videos in YouTube. It's really cool. There's one at a site called Half as Interesting. You looked it up on YouTube. How a manhole cover became the fastest moving object. In fact, listen to first. Well, here's what actually. Robert Brown, by the way, had a great comment when people set this whole thing up and put the iron top on it. Brownlee said, it's not going to work. And guess what? He's right. The thing took off. Now they had a camera that was taking exposures at 1 million frames per second. Standard movie at the time, movie film, 24 frames per second. Enough to fool the eye, the things moving. 1 million frames a second. So they expected to catch this iron cap going up, right? And here's an animation that I made to show what that might have looked like, what they expected to see. But so you think you catch the thing coming up. Let's see it. My book has a lot of 3D objects and animations, and I can't stop. All right, we're stuck in permanent loop. Thank you. You've been a very good audience. That's it. Remember saying so there's a great
curious. What?
Bill, although the Japanese division leader and Robert Brownlee kept asking, well, what happens? And Brownlee kept going into technical details. You can see. Again, you can find this online and read it. It's very amusing. How fast does it go? And after a few minutes, this, although it was getting really irritating, how fast did it go? How fast is it going? Was his final thing. So by the time he finally got to the answer, he was shouting, how fast is it going? In word machine. So Brownlee said 6 times the speed velocity. 6 times the speed that we need for something to escape Earth's gravity. Now that's pretty fast. How fast is it? Yeah, the concrete plug in here, nothing. Well, what happened was 3.5 meters, about 12 feet is where the nuclear explosion just runs out of energy. Wouldn't have happened, wouldn't have done anything to the house. Would have done nothing. But what happened was the concrete vaporized and became a superheated thing like steam, blew that cap off super fast. And according to a separate calculation by the owner of the website, 56 kilometers per second, 5 times this speed velocity. Either way, 5 or 6 times, that's pretty fast. You can still see the explosion today in Google Earth or Google Maps. You can zoom in, and there's Pascal. The hole is still there. Pascal as well, and a bunch of other tests. And this is a recent cycle, which you can do at home.
This was just a question about the camera. You said 1,000 frames per second,
A million,
a million.
million frames.
So that was actually,
They
that
caught,
was filmed.
they
right?
caught the cat going on in one frame moment, one. And so from that, they could compute how fast the thing was.
Right, and this was a film camera?
Yeah, that's all they had. No dips. That's incredible. The technologies that we had in the 50s, we tend to forget. Even our ancestors who built the pyramids had some terrific technologies. But
It's the whole reuse of it.
is the whole reusable? I don't know. I don't know. That'd be interesting to look up. I'll try to find out. The question is, what happened to the Iron Cap? Well, we have an answer from astronomy, from stuff coming the other direction, right? Meteors, rocks. When you see a meteorite like this is a boulder about the size of a basketball, right? Feel free to comment.
No, it's a
It's not the
sand,
size of my fist.
sand grain.
No, it's the size of the sand dunes. So most meteors you see are sand dunes like them, burn up nicely. And they're coming through the Earth's atmosphere 11 kilometers a second. Typically, this Leonid was coming in over 40 kilometers a second, times 0.6, 24 miles per second. The atmosphere, the thickest part of the atmosphere is called the troposphere. It's 5 miles thick. So how long does it take this thing to go through the troposphere? Like that. Instantly. And that's why they burn up. So if the iron cap is going up fast enough, does it survive? That's the question. You can actually compute this. We know that the cap weighed a ton, which is just under a metric ton. Right? A kilogram is 2.2 pounds. 2,200 pounds is a metric ton. 900 kilograms, that's pretty heavy. You can compute the energy it would take to burn this thing up. Whoops. So many joules. We know that the heat of vaporization of iron is sort of many of more of a million joules per kilogram. Multiply all this out, you come with 11,000 kilograms when you burn it up completely. Is 11,000 bigger or smaller than 9,000? What happened to the iron? Vaporized. Well, someday you'll be visiting the Nevada Test Site. Don't try to go in. There's people who did a special, so this is a TV special on history, story television. And when you go close to one of the entrances, you'll see a surveillance car and some drones and cameras, and they're keeping a close eye on people. So they don't want you in. It's a lot of very high security testing going on. Who knows? Experimental with aliens. I don't know. But you can visit right over here the Area 51 Alien Center. Anybody ever been? No, I haven't. And you might be bringing along your memory. Maybe just maybe my advice. So I'll leave you with a quote from George Carlin: "If I ever lose my mind, I hope some honest person would buy it and take it to law school." You've been a very good audience. You can find me here at astronomymotion.com. You can play with 3D objects. You can see some animations. The book will probably look nothing like this. This is a mock-up that I'm doing. But look in the future for space history mysteries. Wish me luck. I'm looking for an agent. I want to say you've been a great audience. Thank you very much. Oh, questions? Any questions?
Manhole cover,
Yes.
which I've always found fascinating. On the way up, just the aerodynamic drag. One would not build a rocket.
No,
One will slow it down.
yeah, who knows what angle it went up?
Well, if it went up, it'd be spinning.
Yeah,
So there's a lot of other energy dissipation besides heat.
yeah, I wonder if,
It might have slowed down enough not to burn.
yeah, in fact, in the book, I've read a short science fiction story about an engaged couple looking for lost engagement. We find something. But that's a good point. We don't know. We're still, yeah. So that's lost. The asteroid's been found, and there's a whole bunch of other topics we look, including planet Vulcan, the canals of Mars, all sorts of interesting things. So I hope to get that done this year. Great question.
Okay,
Well, everybody's still awake.
Yeah.
Question.
The artificial satellites that are seeing this, so the half-life of those materials that are used in those, people will look for being perpetuity, like I found that it's
Yeah,
in the next 10,000 years, before the minerals degrade. And I don't know how that works in space, like I know on Earth, it's very.
ultraviolet light radiation from the sun,
Yeah.
the great material somewhat, but a lot of that stuff will survive just about forever. In fact, our Voyager 1 and 2 spacecraft could be picked up. People know that the aliens would know where to look. You know, a lot of our space probes, if anything happened to the human race, those space probes that we sent out billions of miles out into space may be the last of our monuments. You know, so I hope not. But you're right, we expect a lot of that to survive. Just about there.
And as a control on Earth prediction, would that be different?
I'm sorry.
What my point being, if I took satellite, sent it to space, it could last, let's just, for argument's sake, a million years, right? On Earth, would that be 100,000 years or no, it could be a million years and more?
Depending on how fast it travels, if you could send something close to the speed of light, the time in that object's reference frame is slow tremendously depending on how close it gets. But no, it would weather the same as on Earth. Because there's no, these things are moving very slowly compared to the speed of light. Tiny fractions.
Right.
Yeah, that's a good point. I saw another hand once. Yes.
Just out of curiosity, the remote candle scenario, okay, you said they had ended on that night, they had a deadline, but why was there a deadline? Like, the next day?
They normally would set the thing up and go to rest, then come back the next day to set it off. But they figured, all right, we just finished, it's nightfall, and we just finished, and instead of going trouble of going home and sleeping and some week back in the morning, why don't we set it off right now to see what it's for fun. Scientists and technicians are people, they gotta have fun.
yeah.
Good question. Yes,
Not directly related what you were saying. I just recently read with our recent science of about a program that was, they talked about it 20 years ago, called Breakthrough Starshot,
yes.
using lasers to develop tiny probe. If they never got funding, it was kind of a scandal, I guess.
That breakthrough structure, in case people didn't hear, was planned to use lasers to control a very small probe with sophisticated instruments on a huge light signal, which would collect the energy from the beams and accelerate to tremendous velocities. In fact, yeah, you could get to Alpha Centauri in 5 times 20 years and wait for an answer in 4 years. 24 years, you have an answer. There's no life there. There's no time. That's still being seriously considered. It's a matter of funding. We're still doing experiments with the mylar material to make the light signals. So I wouldn't give up on it. That is probably the fastest way to get to 3I/Atlas, which a lot of you have heard is the third interstellar object discovered passing through our solar system. It's an asteroid coming from outside the solar system, possibly another stars. That's the third one. We could catch up to such an object with a breakthrough Starshot laser mission. Could be done, and there's no consideration. It's all a matter of funding. What do we want to spend on those? I like this gentleman's shirt. I need my hey.
We all see it.
That's it.
I need my space.
I like that.
I'm gonna stick around and after we're all done, putting away my equipment, see if you have more questions or no.
What's your background?
My background, oh yeah, I guess I gave a bio for MMA, so we didn't need it. Yeah, it was interesting in astronomy as a kid. I saw them move into,
That was your
So-
picture, right? That was your little picture.
that was me.
I recognized it. You're up to become a hand.
Yeah, so I looked through a small telescope at the moon and I got hooked on planets. Planets are my favorite aspect of astronomy. So I have a background in physics.
So you're a wanderer.
Yeah, my background's in physics and computer science, but I taught myself other things like computer animation, 3D animation, video, special effects, 3D objects. And there's a lot to learn at the technology is spectacular. When I first started animating, I used 1646 computers in the classroom at the school where I worked. I rendered all of them for 22 hours. I put all those parts together and I got 5 seconds of a bunch of spaceships going over the planet. Now this laptop can do all that in seconds. Oh, it's amazing. And this is available to people to buy, ordinary people like us. Have supercomputers. So it's just incredible. We're living through amazing times. I lived through the beginning of the space age, the beginning of the digital age, the beginning of the age of AI, the beginning of the age of stupidity. So many blessed to be alive.
Okay,
To be able to see wonderful people like you. So I hope to come back and do this again.
okay, thank you, Lonnie.
That's it.
Hey, that's it.
I put some books in, do we have a library?
Huh?
Think we do. Or, do you just want people to pick them up and take them, or
Look, yeah, take them, whatever, name.
Ron, do we have a library?
I'm pretty sure we have a place. for this.
Somewhere we.
Yeah,
can
it's
put 'em.
up on the second floor over here. It's back in the back in here. Probably right over to.
About photography, she's standing up.
Okay. We'll do that. You find a way to get them where they're supposed to be, I guess. Thank you, Ron. Okay, just a reminder, next month's meeting on the second Saturday of November, which is, I think, November 8th. It'll be at the Morris County Library, not here, okay?